Yeah, essentially we will jump a little bit from authentication on-chain to authentication off-chain. And because you might rightfully ask, why do we talk about this at a blockchain conference? I'm going to try and use the first part of my talk to give you a bit of an introduction, because I assume not everyone here is familiar with it. We had a couple of people refer to it already, although in a couple of talks yesterday also and today. So I want to talk about self-sovereign identity a little bit and how it relates to blockchain. And then I'm going to talk about our recent efforts in making it more integratable. So this is that paper. We had a context of a Gaia X data space project, so business to business. And of course, you need identity also when you share data in a decentralized way. We all know how identity looks like for consumers today. It's usually at this point federated social logins of some type, email and password accounts everywhere, and it has consolidated a lot into the hands of a couple of big players that are integrated into almost every service at this point. So that is, federated identity management today. And of course, that has a couple of issues. I already said it, it's very consolidated on a handful of players. So we have centralization here. We have, of course, the reliance on passwords with these accounts. That is slightly also changing via passkeys, which we saw right now, but that's also still not really there in practical use, at least. And the big identity providers essentially have a lot of power in terms of the data, because they are an active intermediary in every sign-in process. And they, in theory, of course, can also censor either individuals or groups, or they could simply have a service outage. So similarly to also the idea of blockchain, decentralizing money, decentralizing business logic, why not decentralize identity to obtain similar benefits? This is kind of the first connection here. So we had centralized identity mostly in the beginning. Every website hosts its own user directory. We are mostly at the federated ID zones today, and decentralized identity is probably where this is going in the long term, where everyone, in a sense, administrates their own ID, getting bits and pieces from identity providers and resharing them at will and whenever necessary. So what is now self-sovereign identity? That's kind of the term for this goal. And you can see on the left here in a conceptual way how every sign-in procedure today essentially works. You as the user instruct your identity provider, be it Google, Facebook, or whoever else, to negotiate the sign-in for you. And they share the data with the actual relying party, so the service you are trying to log into. And you are essentially just a bystander in this process. You fully depend on the identity provider doing it for you. And the idea in decentralizing this is also to get the user into a more active role again, to not involve the identity provider, which is now an issuer of certification material, to not involve this issuer in the process directly anymore. And by this means, of course, you gain censorship resistance, you gain potentially, at least, that of course depends a lot on implementations, you also gain privacy. And of course, blockchain technology, that's the next link, can be a pretty good means for creating and publishing these accounts, publishing metadata, dealing with key replacements or different signing keys for different functionalities. All of this can be done on blockchain. So the standards that I'm mostly working with are the ones from the W3C. Certainly not perfect, but at this point, pretty decent to work with. You have an identifier standard, and you have a standard for claims. So decentralized identifiers for the identifiers, very flexible standard. That's kind of a blessing and a curse. and the verifiable credentials, which are then the claims. So with claims on the one side and and verifiable credentials on the other, with claims and identifiers, you have identity. And just to get a rough idea in this crash course how this works in practice or looks like in practice is you have an issuer, which could, for example, be your university, that issues a credential, which could be a digital representation of your diploma. So usually that is signed JSON data to you as the holder. You keep that potentially on a wallet on your device, which is very comparable to a crypto wallet because your identifier in the end also is just cryptographic key material. And then at any future point in time, you can present this to a relying party. So, for example, you have obtained a bachelor's degree from your university at some point. Now you want to enroll for a master's degree program. So now you can go to a different university as a relying party and prove that you do own indeed, or you have obtained a bachelor's degree in the past. And for things such as key lookups, in case of the identifiers, or also for revocation, you might need additional data, which is what this verifiable data registry at the bottom is, which once again could be a blockchain. That's a pretty decent candidate. The specifics are still not very mature. There's a couple of proof of concept systems, but to my awareness, I don't think there's anything that is currently running in any major way. So now to get towards the problem here, I brought this SSI stack from Project and Reed. Drummond Reed is fairly popular name in that scene, so maybe you've heard of him before. And he essentially, similar to maybe OC network layers, defined the stack here that reaches from the factors of technological trust at the bottom up to the more social factors. So you have identifiers, interfaces, credentials themselves, and the governance that fits it all together. And if you want to now adopt, even just as a simple service provider, you want to adopt SSI-based authentication, there's a lot of open questions at this point. There are questions on the identifier level of which identifiers exactly do you use or support. There's questions on the interfaces level, what interfaces can you even use, what interfaces do you want to support? Are these interfaces then in turn also supported by sufficient wallet software? That's all pretty difficult right now. Credentials is maybe the most settled part of the architecture, but then there are still questions about the exact data format within the credential. And governance at this point is essentially the Wild West. Big questions about who do you trust, who is allowed to issue certain things. Also a question that I think was discussed yesterday in the talk was this question of who is even allowed to ask for proofs, because that might also be a reasonable question if that should not be regulated, at least for certain high impact governmental proofs like digital ID cards in the future potentially. So all in all, it's kind of a nightmare to actually adopt this. And it's also, it doesn't even matter here whether that's for a proof of concept or for actual productive use. Even for proofs of concept, this is already pretty hard to properly get off the ground. So there are solutions to this. And one solution, which people, of course, already had way before me, is this question of why not use established identity and access management systems. So there's a couple here, but especially in the internet of late, also with Google and every other big federated identity provider I mentioned before, they are relying on OpenID or OpenID Connect. So that is extremely widespread. That has amazing developer support. If you've used any web framework in the past 10 years, it probably has at least 15 different OpenID Connect libraries. So this could be an easy way to bridge this gap between SSI and actual running services, be it existing services, older services, or even new developments and proof of concepts. And yeah, this was also identified in prior surveys, and a survey that actually looked into these integrations 2 years ago found that essentially there's only 7 works on this at overall in total, and only 2 of them have any sort of source code available. So it's really hard to find anything usable here. This is the gap we want to try to close. And just to give you a brief idea of what existing solutions look like here, this is a pretty interesting publication which tries to build a very holistic system. You don't need to be able to read everything here. That's kind of also partially the point. They essentially try to build a almost fully complete multiplexing system between different sub-ecosystems of SSI, between OpenID, between SAML, also issuing in both directions. And as you can imagine, this becomes very complex, very, very fast. And that is also visible on the performance side, as you can see on the right side. Just the best case, just the technical runtimes of a best case login here, which is their scenario number 3, is somewhere in the range of like 5 or 6 seconds. This is without any user delays. And you can see how badly it scales once you start to actually have concurrent users. So this is not really feasible for any, even just piloting. We tried to simplify this a little bit and just look at sign-in procedures. And that means we lose the complexity of having to issue into both directions. We do not issue at all, because the rationale here is there's only a handful of issuers in general in any field, and they usually have the capabilities to modernize, to update. But there's hundreds, if not thousands, of smaller services who would potentially like to use the technology, but they simply have too high of a technological barrier. So what we essentially do here is we bridge between OpenID Connect and the new also OpenID protocols for verifiable credentials, because they are pretty fast in proving themselves as the de facto standard for wallet integrations. So in theory, a very large share of existing wallet software is compatible with this. And then we essentially have defined the system that negotiates the entire login between the normal core OpenID Connect and the new cutting edge and not even ratified standards for the verifiable credential presentation process. And what you can roughly see here is we have the OpenID Connect provider, which interacts with a client which is running on a browser. And we have a custom relying party service that is interacting with the smartphone wallet. And then there are a couple more aspects to this, which I'm going to gloss over here in the interest of time. But essentially, what you can do now is you can try to use an established OpenID Connect provider, which is also what we did for our implementation. And then you implement everything else yourself. And then you have a finished implementation. So the main part that we try to improve on also here is the configuration process. So obviously, when you try and start to integrate so many different protocols, you run into a lot of configuration files you suddenly need. And obviously, that is also a barrier of entry, that you now have a security critical system for your sign-ins for whatever platform you operate. And you need to now learn about all of those configuration formats. So we try to unify this here in one JSON-based format, which combines trust, who am I accepting credentials from, combines also required values, because this is usually, in the end, what you mainly need. You know what values your system needs, especially maybe if it's a legacy system. You know you need maybe an email, a first name, a last name, an address, whatever else you might also have gotten before from normal OpenID Connect providers. And you can specify all of this with, of course, the knowledge that there is someone issuing this as a credential. This is, of course, a prerequisite. And then this in our system is compiled down or translated essentially into a presentation definition, which tells wallets, according to the OpenID protocol, what is expected to be presented. This is not security critical, at least not in our system. It's only used so that you as a user get a nice pop-up in your wallet that already pre-selects the possible to present credentials. So this is purely usability. We then actually use this also for as a policy for compliance on the actually presented credentials. And finally, we also use it to process the claims. So especially if you are using a legacy system that you want to onboard, or for any other reason, you might need to rename claims. The example here, for example, is for emails from 2 different providers. So there's a chance that they name their email field differently, with underscore and without underscore, and you can use the policy to get the names to be equal. So this way you have normal OIDC tokens, and it is compatible with any OpenID Connect client. Just for you to get an idea of how this actually looks on the user side here, we did a couple of integration tests, one here with the good old WordPress. You just click on the login button below the standard email and password login. You get forwarded to the IDP server. It shows you this QR code that you scan with any OpenID compatible wallet. We are using AltMe Wallet here, which is an open source solution from France. And it now automatically prompts me for a verified email token or credential. I just click on it to confirm it. Everything happens pretty much instantly in the background. And on my browser, I'm getting forwarded and logged into the page with my new session. So the user experience is very straightforward. We haven't done formal benchmarking yet, so I cannot really tell you the technical boundaries. But if you just give it to a user who broadly knows what they are doing, so with human delays here, you can get easily 6 seconds and below. So what's next? Of course, one question is how can we extend and validate the policy language? We want to include constraints. We've also started doing that already. So on the GitHub, there's also already a branch with an extended policy language. But of course, at this point, also inspired through some talks yesterday morning, I'm beginning to wonder, would it also be relevant here to look at XML-based policy languages that are established? Because as soon as we start blowing up now the complexity of our custom policy, there might be a benefit to switch to a policy language that's established, or maybe ODRL policies. And then, of course, this question, once that is finished, how intuitive is it actually? Probably doing a couple of user trials, doing formal performance evaluations, security evaluations, and also, of course, using it in our GaiaX dataspace project and continuing on using it to just see how it fares and what issues people run into. And yeah, you can see the code here. If you want to have a look at it in your own time, maybe even want to build something with it, feel free. It's all open source. And thank you for listening.
Okay, great. Thank you, Felix. Yes, please.
Thanks a lot for the talk. This topic is very, very relevant for industry. And from the aspect of organizational identities, which is also going to be in a decentralized way envisioned by the European Union through EIDAS. So what is your take on that? That'll be one. Maybe also another question is, as you mentioned, this is being standardized and it's still not written on stone as many components are being moving around. Would it make sense for you to be involved in the standardization body so that you can push your research there so that everybody could use it? Because if you again span out of the standardization, propose your own stuff, it might be less adopted. So just a suggestion, question.
That is all valid. So first question was about the organizational identities. That is, of course, also, especially in this GAIA-X context, a big question mark, or not that much of a question mark. There are, of course, proposals. Mainly right now, and I am actually involved in that standardization group now to some degree, because right now the only way to bootstrap an organizational entity is via TLS certificates for the web, which in my view is a dumb idea. Why do you build something decentralized and then the only way to bootstrap it is to go via TLS? I don't think that's a particularly great idea in the long term. And this is stuff we are discussing. Let's see what comes out of it. And otherwise, I think the organizational identities mainly depend on the software, because they usually need to issue some sub-credentials, for example, employee badges. So there are benefits to having them on servers online, which of course now becomes a different interesting security topic. What we have been also investigating is completely doing that with on-device signatures and smartphone wallets, but that also has limitations. The only thing I really do not like here is certain approaches of doing this fully as a service, because again, why do you decentralize these things if then in the end there is one German telecommunications company who shall not be named that wants to host all of those keys, private keys, in their centralized cloud? That there is a certain dissonance here.
Okay, given the timelines and standardization, I understand you've just received a permanent job offer from Siemens.
We talk later.
Excellent. All right, one last question. Thank you.
Given that you were, you said that essentially these W3C standards were pretty complicated, and as far as I understood, I guess they're also quite ambitious and quite general. Do you think it would make sense to try a different standard and like tailored to some use case? And what would that use case or use cases be?
Okay, that's a good question. So maybe I need to partition this a bit. The standard of verifiable credentials is in a pretty good state at this point, I would argue. There is some chaos because the signature can either be JSON LD based or it can be JWT based. And there is a lot of back and forth. Right now, I would say that JWT based signatures are slowly but surely winning. This is one of the things I do not really have a strong opinion on, but this is definitely creating a bit of chaos, because as soon as you find something that is SSI or verifiable credentials, you need to be aware that it could just use either of the two signature types, and then it's not compatible to what you are doing. But that will probably fix itself. The more ambitious problem is decentralized identifiers. The standard is very cool in the sense that it's a meta standard, and you define exactly in sub-methods or just methods how this key material is stored, what additional metadata you can define, how the administration is done, CRUD operations. And that means from a website to just a key without any extra functionality, or a ledger-based identity, everything is possible. And that, of course, now means if you want to be truly interoperable, which is a key goal of SSI, you technically need to support all of that. So, and you can realize that it's probably not feasible to have blockchain integrations for at least 25 different blockchains, if not more. Probably, if you want to support everything, you will never get it done. So the question is, can we limit this standard space somehow, or is it actually possible in some weird way to build a true universal resolver for these methods? I think that is the main problem of complexity right now.